The goal of this lab was to determine the relationship between increasing salinity levels and percent seed germination. At a point, the salt concentration of water will negatively affect the ability of seeds to germinate. The purpose of this lab is to determine the point at which the seeds are unable to germinate by testing different levels of salt concentration.
Because the salinity of the ocean, 3.5% concentration, cannot successfully germinate seeds, and 0.005 is the percent concentration of fresh water, the radish seeds will germinate with the fresh water and with all solutions below 1.5% concentration. If the seeds are water, with a solution that has a concentration of over 1.5, then the seeds will crack but not germinate. The materials used in the experiment include petri dishes, distilled water, paper towels, tweezers, labels, graduated cylinders, Ziploc bags, salt, test tubes, and pipettes.
Procedure. Number 1. Label 6 petri dishes with the salinity of water that will be used to water the seeds in it. One dish will be pure water, serving as a control for the experiment. Then the next will be 0.5% concentration. The following four will increase in percent concentration by 0.5 respectively. 1, 1.5, 2, and 2.5 salinities. Step 2. Place 15 seeds in each dish carefully using tweezers or clean hands. Number 3. Water each seed with 1 milliliter of their respective solutions. Be careful here. Number 4. After watering, place the caps on the petri dishes to ensure that evaporation doesn't change the concentration of the solution. Number 5. Final step. Almost there. Continue to water them every other day with 1 milliliter of their respective solutions. Check seeds daily and record how many seeds have germinated each day. In our results, we found that the seeds watered with distilled water were the most successful in germinating. However, other seeds were able to germinate as long as the salinity of the solutions was below or equal to 1.5. The seeds watered with solutions that had salinity levels of 1.5 or less germinated within 3 days. In the final days of the experiment, the seeds watered with distilled water and water with 0.5 and 1.0 salinity levels continued to germinate, while the seeds watered with percent concentrations of 1.5, 2.0, and 2.5 showed little progress or no progress at all. Astounding. Seeds watered with solutions that had a percent concentration with less than 1.5 continued to show progress over the course of the 5-day experiment, while the seeds watered with a solution of 1.5% concentration had little progress and were only able to germinate one seed over the course of the 5-day experiment. The seeds watered with solutions of salinity greater than 1.5 did not germinate at all because the concentration of salt was too high. Truly remarkable results.
After reviewing the results of our lab, the conclusion was reached that as the salt concentration rose, the germination rate of the radish seeds decreased. The freshwater solution was most successful in germinating seeds, but the zero point 0.5 and 1 concentrations also had success in germinating seeds. The one seed that germinated after being watered by a solution with a concentration of 1.5 was an anomaly in the experiment, but the fact that only one seed germinated still verifies that the solutions of lower salt concentrations germinate more seeds. This error could have resulted from underwatering the petri dish so that the effect of the high concentration was reduced. Our hypothesis was partially correct. The solutions with concentrations less than 1.5 salinity were the most successful in germinating seeds.